What is up, guys? DevCode here. So now that we've pretty much gotten all the errors out of the way, now it's actually time to start building our Tokenizer class. So the first thing we need to do is we need to create our private variables so that way we can access them in our Tokenizer. The first variable we're going to need is we're going to need a list of token entities, and we're going to call it entities. Next, we're going to need our error manager, and we're just going to call it errors. Next, we're going to need a list of strings so that way we can have our lines of code. Next, we're going to need a string of our tokens and another variable called empty. Next, we're going to need to have an unsigned long called len so we can get the size of our tokens in our tokenizer. Next, we're going to need an unsigned long called cursor, which is basically just going to point to where we are in our string or set of tokens so that way we don't get lost. And then of course we're going to need an int of our lines and our columns so that way we can keep track of where exactly are we in our file. Alright, so now that we've gotten that out of the way, now we need to create a set of functions for our tokenizer so that it can work properly. So first we're going to start with our private functions, and that's going to consist of a parse function so that way we can just parse our code. We're going to need a function to be able to parse all of our lines. We're also going to need to know if the char that we're comparing against is a match. Next, we're going to need to have a function called getEscapedString. More on that later. So now that we have that, we can start creating our public functions. So our first function is going to be a constructor that's going to just initialize all of our variables to whatever they need to be. I've also created a public file function so that way we know what file our tokenizer is processing. And we're basically just going to set everything to its initial value with the exception of len, so that way we know how long our tokens are, and file so we can know what file we're processing. Next, we're going to need to initialize our list. So we're going to need to initialize our entity list, and we're also going to need to initialize our lines list. After that, we need to set a specific token called EOF token. I've also created this as a public variable as well. And basically what this token is going to be is this is going to be the last token in our actual file. So this is just basically going to be an end of file token, basically signifying that our tokens are basically over. So the first thing we need to check to see if our tokens are empty or are not empty. And if our tokens aren't empty, then we want to just assign our tokes function equal to our tokens. Otherwise, if it's empty, then we just want to set our tokes equal to nothing and our len equal to 0. And then after that, we want to just call our parse function, and that's going to go and actually do the parsing of our data. Alright, so the tokenizer is a pretty simple class, so we just need a few extra functions just to make it work. So the first function that we're going to need is a getEntityCount function. That way we can get how many total token entities we have. Next, we're going to get our actual entities. So we're going to be able to get our list of entities. Next, we're going to have our getErrors function, which is just going to return our error manager so that we can check to see if we have any errors available. Next, we're going to need to be able to get all of our lines in our code. And then finally, we just want to be able to get our data. So what is the actual data that we've processed here? Alright, so before we get started with writing our tokenizer, I just want to show you guys my GitHub repository. So for those of you who are following my series, and maybe if you missed something in one of the episodes or you were a little bit confused, you can always come back to this repository under androdevcd/sharp, and this is the repository for my programming language. And there's a couple of different branches here that I want to go through. So the master branch I actually haven't worked on at all. I don't do any coding on this branch anymore. This used to be my main branch. So the branch you would see me doing daily coding on is actually going to be called remastered. So if you guys ever want to see any updates with the programming language or anything that I'm doing new, you can just check out the remastered branch to see. And in fact, I've actually just did some recent commits to this branch less than an hour ago. So the reason for the remastered branch is this is basically going to be the official version of the actual language. So the code that you guys are going to be seeing me write in this YouTube series, some of the code there might be a little bit outdated slightly, but it's not going to be too far off of what the actual language is doing. So the code that I'm going to be showing you guys, I'm going to be writing all in our LMAPL series branch. And this is basically going to hold all the code necessary for every episode. So essentially for every episode, I will just put a new commit that's going to hold all the code that I wrote for that entire episode. And you can just look through there and see what I changed and see what you may have missed. Also, any other branches in this repository are pretty much unused besides remastered and Let's Make a Programming Language, so you can ignore those. But if you guys want to support me, then definitely hit the star icon and give me a fork so that way I can get more traction on this language, because my goal is to get this out to thousands of programmers so that they can test it and I can improve the language. Alright, so now that we've written all the code that we need for our Tokenizer class, we can just start writing the functions one by one. I'm actually going to include a link below the video for any of you guys who may be confused about what a tokenizer is or what the purpose of a tokenizer is. There are already YouTube videos out there explaining this topic, so I'm not going to go into any detail regarding that, but if you guys are curious, you can check in the links below. So the first function that we actually need to create is going to be called an isWhitespace function, and it's not really a function, it's just more of a defined statement. And the reason why I made this a defined statement versus a function is that we want to optimize our Tokenizer to run as fast as possible. So it will be much faster if we just pass in a char here and compare it against this if statement here, rather than if we had to call a function and pass this data in. Next, we're going to need something called current. And what this is going to do is this is going to take our cursor or our current point that we are in processing our code, and we're going to just check to see if that's less than the length of our tokens. If it is, then we basically want to just get the token at that cursor or at that address and return it. Otherwise, we just want to get whatever the last token is in our list. Next, we have new line, and all that's going to do is that's going to set our column back to 0 and set our line to 1+. So this is going to be useful when we need to start tracking our lines in our code, so when we report errors, that way we know where we are exactly. Next, we're going to have another define statement called isIn, and all that's going to do is it's going to check to see if our cursor is greater than or equal to the length of our actual text. Next, we have peekIn, which is basically going to check to see if we can jump forward a certain number of characters. After that, we're going to have a defined statement called peek, which is basically just going to check to see if we can move forward a certain amount of characters, and if we can, we will return what we are plus a certain amount of characters. So if we wanted to process this peek and we wanted to just peek forward one more to see if we are holding a left parentheses, we would use this for that. Otherwise, we just return the last token in the list. Next, we're going to have a defined statement called isSymbol. And what that's going to do is that's basically going to check to see if the character that we passed in is equal to any number of symbols that we allow in our programming language. So it can be a math symbol, it can be a question mark, or any one of these other symbols here. Next, we're going to have isNumber, which is just going to be a defined statement that calls a function called isDigit, which is just going to check to see if the character that we passed in is a number. Right after that, we want to be able to check to see if we have a letter, so we're going to call the function isAlpha, which is going to check to see if the character we passed in is an actual letter, whether it be lowercase or uppercase. Next, we're going to need to have a defined statement that's going to check whether or not the character we're passing in is a hex number. So of course we have our isDigit here because a hex can be simple digits, but we also have this little if check here that's basically checking whether or not our hex number, in air quotes, is A, B, C, D, E, or F. Because these letters are also a part of the hex number values, so we want to check for these as well. After that, we simply want to have an advanced function, so we want to increment our column and our cursor. Next, we want to know how many tokens we have left, so we're going to create a defined statement that's just going to do our length minus our cursor to see how many tokens we have left to process. Next, we want to be able to check whether or not our token is assigned, so we're just going to do our simple plus and minus signs. All right, so now that we have our basic define statements kind of out of the way, now we can start just writing our functions so we can start processing our text. So first I'm just going to create the function very simply to get the entity count. It's just going to return our entities.size. And if you guys remember, a token entity is basically just a exploded version of a character token. So if we were processing this class token right here, CLASS, then that would all be considered one token and it would be considered an identifier. And it would have that information in here. So it would have what line and column it's a part of, the ID, so it would be labeled as an identifier. It would actually have the actual text, which would be class, and the token type would be whatever that is. After that, we want to just be able to get our entities. So we're just going to simply return our actual list. Instead of getting the size, we're going to return the actual list. So next, we're going to just start coding in our parse function. So the first thing we need to check to see if our len is equal to 0, then we just return because there's nothing to process. After that, we want to call our parse lines function, which we will create next. So in here, we just want to have a string stream of our line that we're going to process, and we're just going to go through and process all of our code. So we're going to have a for loop. We're going to have a long I is equal to 0, I is less than len. And then in here, we're just going to check to see if the token that we have at our current index is equal to a new line, then we just want to add this line. So what we're going to do is we're going to set our line.string. So we're going to get the data in our string stream, and we're just going to pass that through, and we're going to set our data back to empty. Now, if it is not equal to new line, we're just going to say line. We're going to take the current token at the current index. And just in case if the file that we're processing has only one line of code, just to make sure that we add that, we're just going to check to see if our line.string, so our line string up here, isn't empty, then we just want to add that line. Because if we were processing this and we never came through this if statement, we're never going to clear out line, so it's going to still have text in it. So we just pull that out and add our one single line that we have here. Otherwise, line is going to be emptied out and this if statement will never run. Okay, so after we parsed our lines, the next thing we need to do is set up our errors. So we're going to set our errors equal to new error manager. Now, this is where our error manager starts to come into play. So first, we're going to need to pass in our lines. Then we're going to need to pass in what file we're processing. And if we go here, we can actually see the constructors. So first we need our lines. Next we need our file name. After that, we're going to say whether or not we're printing as is and whether or not we have aggressive error reporting. Now in this case, since we are tokenizing our code, we don't want to print as is because we may be running into some errors and we don't want them to directly be printed to the console immediately. Next, in order to set whether or not we want aggressive error reporting, we just call our C options and we say dot aggressive errors. We're actually getting a compiler error saying it's inaccessible, so I'm going to go here and make this public, and then all of these functions will be public as well. So right now we don't have any way to set this flag aggressive error reporting in our different options for our compiler, but we will be creating that so that way we can set this flag in all the others so that we can use them in our compiler. So first we're going to need a for loop. It's going to be a for loop that runs forever. And in there, we're going to need to create a label called start and another label called invalidate whitespace. The first thing we need to do is we need to run a loop that is a while loop. And basically, the purpose of this is we want to clear out any whitespace that we have in our code. So let's say we were processing this new expression here. What we would do is we would want to remove any bits of white space in between all of our text because that's not important. Once we have that, we want to just check to see if our current token is equal to a new line. And if that's the case, we want to call new line. And new line is just going to set our column back to 0 and increment our line. After that, we want to advance. Next, we want to write some code to invalidate our comments. Typically, every programming language has about 2 different styles of writing comments. So you have, of course, your single line comments, like in C++ and Java, where it's just a simple // And then you also have your multi-line comments, which can be used for documentation purposes or just comment purposes. So it usually consists of a minimum of a / and a star, and it ends in a star and a /. So that's the next thing that we're actually going to be processing. The first thing we need is we need an int called mode, which we're going to assign to 0. After that, we need to have an if statement that's going to check to see is end or peak end. And if that's the case, then we go to scan. We're going to create that next. That's just going to be another label that's going to be below us that's going to start doing our scanning. And if you guys remember, peek in is basically used to see if we can advance forward a certain amount of characters. Otherwise, we're going to have an otherwise statement that's going to say otherwise if not comment start. So we're going to pass in our current token and we're going to peek forward 1 token. We're going to pass in our mode. Then if that's not true, then we're also going to go to scan. So next we're going to need to create this comment start function. Basically, all this function is going to do is, it's very simple. You pass in a constant char, so your first char, and then you pass in a second char, and then you pass in your mode. And we need to pass in a reference here because we're going to be setting this mode to whatever it needs to be. So to put it simple, the way that we're going to decide whether or not what comment we're processing is if we look here. So if you look at this comment, the first single line comment starts with 2 slashes, and the second one has a slash and then a start. So we're just going to first of all check to see if we have a slash at all. So is this even a comment in the first place? And then we're going to check to see if it has a slash immediately afterwards. That means that it's a single line comment. Otherwise, if it has a star immediately after the slash, that means it's going to be a multi-line comment. So for single line comments, we're going to set our mode to 1, and for multi-line comments, we're going to set our mode to 2. Otherwise, if it's neither of these, then the mode will be set to 0, or it will stay at 0. After that, we just want to increment our column and our cursor. So in this case, we know that comment start has actually succeeded. So that means that we found the start of a comment, because otherwise we would have never gotten here because we would have jumped to the scanning portion of our function where we're scanning data. Since this is a comment, we don't need to save any of the tokens in the comment. So we're just going to skip past the first 2 tokens and we're going to advance our cursor. After that, we're going to have a simple while statement that's going to be just as trivial as our if statement above. So we're just going to have a while statement that's going to check to make sure we're not at the end of our file and check to see if we're not at the end of our comment. And we're going to pass in our mode so that way we know what comment we're dealing with. And then otherwise, if while we're processing our comment, the current token is equal to a new line, we just want to advance our new line. So we want to increment our line and set our column back to 0, and then we just want to jump to the next character. So now we're going to go and create our comment in function. This function is also going to be pretty straightforward. We just pass in both of our characters and then we pass in our mode. So in this case, we don't actually need to pass in the reference because we're just reading it, we're not writing to it. So what we're going to return from this comment in is we're just going to see if our mode is 1, and if our current token is equal to a new line, then we know we're at the end of our single line comment. Otherwise, if we have a multi-line comment or mode 2, we just want to make sure, have we reached our star and our slash? So on our multi-line comment, just basically going to start with this, so a slash star, and then we finally reach the end when we hit the star slash. After that, we want to check to see if our current token is equal to a new line. Again, we just want to set the new line here. And the reason why we need to do this is, let's say we ran into our comment and it's a single line comment. Well, what we're going to do is we're going to check in this while statement that we're not at the comment in. And what we're going to do is pass in our current token. And if this returns true, the code inside of this while statement won't run because it won't evaluate to true in this while statement. So we just want to make sure that we account for it here by setting the new line if we need it. All right, so after we do that, we just want to check to, again, make sure we're not at the end of our file. This is going to be something recurring that in our tokenizer, basically anytime we're reading from any type of text or doing anything at all, we need to always make sure and do a sanity check to make sure we're not at the end of our file. That way we don't run over the edge of our tokens and just be processing the end of our token forever. So if we're not at the end, what we need to do is we need to just increment our cursor plus equal to mode. And the reason why I do this is, if you remember above, whenever we have a single line comment, mode is equal to 1. And if we have a multi-line comment, mode is equal to 2. So in this case, a single line comment ends with 1 single character. So when we increment our cursor, we jump past the new line that we would have processed here. And if we have a multi-line comment, that ends with 2 characters, and the mode is also going to be set to 2. So then we just jump our character those 2 places. Then we're going to have an otherwise statement that's going to check otherwise if we're at the end of our tokens and the comment has not ended, then we're just going to create an error here and say expected close comment before end of file. So this is actually going to be the first error that we have reported in our compiler. And basically, if we're processing this while statement and we reach the end of our file, this is end check is going to evaluate to true. So then this is going to jump out of here and it's going to come down to here and realize that we're at the end of our file, but we haven't processed our code for our comment, and we'll just create the error here. And in this case, since we don't have an error for a comment not being closed in our file, we're just going to create a generic error, pass in our line and column, and then just tell the error straight to the error management system on what the problem is. So next we're going to need our scan label. So this is where we actually start scanning our code. So the first thing we need to check to see is if we're at the end of our actual text, we just want to go to end. And I'm going to create that now. And basically what end is going to do is at the end of every single file, we just want to add our end of file token as the last token that we process. And make sure that your end label is outside of this for loop here. That way we don't run into this for loop forever. So this ensures that we will always exit out of here once we pass through our file. So the first thing we're going to need to check for is we're going to need to check for our double character symbols. So let's say we had a symbol like plus equals or minus gets or divide gets, something like that. Anything that has a set of 2 symbols that make up one operation or one type of token, we're going to process that inside of here. So in order to check that, we just need to create a token type, and we're going to create an array of chars. And what that's going to hold is that's going to hold our current character, and then we're going to just jump forward 1 character and see if we find any of these double character tokens. So the first we're going to check for is if our chars at 0, so basically if our first token is equal to less than and our second token is equal to an equals, then we know this is less than or equal to. So we're going to set our token type to less than or equal to. So I've added the rest of them, and basically all we have is we're checking our first and second char, and we're looking for greater than or equal to, not equal to, equals equals to, or equals equals. So like let's say if you had a string, like kind of like how we're doing here, seeing if our character is equal to some other value. So we're going to have our equals equals. We're going to have our shift left, our shift right, our and. So something like this where we're doing and comparisons to check for if something is true. We're going to have our binary or, which is going to be 2 ors this, which are going to check for if one or some other value is true. We're also going to have a pointer thing. So kind of like in C++, where if you have a pointer of a set of data and you say data and then you do a pointer and then you access field. So let's say data.name. In our language, we're also going to have something like that where we use a pointer to access data. So we're going to need that character, multi-equals, and so on. So again, for whenever I paste in a big chunk of code that's kind of repetitive, and if you guys are actually following along, you can just simply go to my GitHub page and literally do a copy paste and you'll have exactly the same thing that I wrote here. So after we do that, then we just want to do a simple check. So we want to see if our type, our token type, is not equal to token none. So if we've actually processed a token, then what we want to do is we want to create a string. So we're going to have our string append our first and second character, which is going to be our less than or equal to or any of these other tokens. And then we're going to add our first token. So as we're processing all of our tokens, this is generally how it's going to look. So we're going to have our list of entities. So if we go here, this is our list of our token entities. So as we're processing our tokens, we're going to create a new token entity class, pass in the string of our actual token. So one of these, and then we're going to need our type. So this is where our token type, and we go here, our token entity ID comes in handy. So if our token is a single token, then it's not going to be a token entity ID. It's not going to be a higher level type of a token. It's going to be more of just a simple token like minus or plus. Then we're going to need our column, our line, and then of course we're going to also need to know what token type it is. So if we go through this list and we see that we haven't found a 2-character token, then this if statement is going to be skipped, and then we're going to be outside of that if statement, and we're going to start processing our single character tokens. So I'm going to explain the first one, and then it's going to be pretty repetitive after that. So we just check for a single token, so something like less than, and we see if that's equal to our current token, and we just do the same thing. So we add our token, and we set our token type to a single token. We get the actual token into a string and pass it in our token entity class. We set what type of token it is, so that way we can process it, and then we set our colon and our line. So there's quite a few tokens that we're going to process. I'm not going to go through all of these, but you can kind of see them here. If you guys want to pick up this type of code, then you can look at my GitHub repository. Basically, we have pretty much all the different type of single tokens that we're going to process in our language. And finally, if our token is not any one of these, then what we're going to do is we're going to actually complain about an actual error in our compiler, so unexpected symbol. We're going to have some pre-canned text that's going to go before this, so it's going to basically say unexpected symbol right here, and then we're going to pass in a little asterisk, and we're going to pass in what token it is and another asterisk. So our error should look something like this, where we have our unexpected token, and then we have exactly what token it is that was unexpected, so that way the user knows what they ran into. After that, we're just going to advance our token and go to start. So we're going to just jump all the way back up to the top here and start checking for white spaces again and checking for comments again. So next we need to check to see whether or not our current token is a letter. We also will need to check to see if our current token is equal to an underscore. So if you go back up here to our grammars.txt file and you look at our definition of what an actual identifier is, we actually say here that the first character can be a letter and any preceding characters can consist of letters, numbers, or underscores. What I forgot to add is to say if our first character is a letter or an underscore, then we basically assume that what we're processing is an identifier, and that will then have to respect these rules after that preceding token for it to be processed correctly. So first we need a simple boolean that's going to say has letter, and we're going to need a string. After that, it's going to be pretty simple. We just check for whether or not we're not at the end of our text. We check for is alphanumeric. So this is alnum is a C++ function that checks for whether or not a token is alphanumeric. In the case doesn't matter. So this doesn't check for like upper or lowercase. It just looks for letter or number. Then after that, we also want to check to see otherwise if we have a underscore, that's also allowed as well. So in there, we just want to check to see is it a letter, and we're going to set a boolean has letter equal to true. We're going to populate our string with the actual identifier that we're processing and just advance our tokens. After that, we're going to check to see if we do not have a letter. Basically, if has letter is not set to true, then we want to complain here and say a generic error of we expected at least one letter and identifier blank. So the reason for this is, let's say you created an identifier called underscore 992. Well, if you had a letter in there like underscore 9C92, that would actually identify or qualify as a proper identifier. But if we never processed a letter in our identifier and we just processed an underscore and a bunch of numbers, then that's a problem. Otherwise, if we do have a letter and we processed it, then we just add our token entity. We get the string of our actual identifier. We set what type it is, our colon, and our line. Once we're done, we just want to go to start, so that way we can continue processing our code. Next, we're going to have another check for is numbers. So this is going to check for hex numbers. This is going to check for decimal numbers. We also allow underscores to be in our actual numbers in our compiler. So if you had something like a cell phone number or something that you wrote in the code, you can have underscores there. But the rule is that our numbers must start with a physical number in order to be considered a number. Just like we had up here, it starts with an underscore for our letters. We assume that all numbers have to start with the actual number first. So the first thing we're going to check for is we're going to check to see if our current token is equal to 0 and our next token, the token after it, is equal to x. So basically, are we parsing a hex number? After that, we just need to create two simple variables called number and underscore OK. And we're going to start our string them off, or our number, equal to 0 and x, and we're going to just jump our column and our cursor to pass these two tokens that we just processed. Next, we're going to need a while statement that's going to jump through our hex number to see if everything's okay. So we're going to check to see if we have a hex number. So if we go up here, whether it's a digit or A through F, we also need to check for an underscore because we can allow that as well. And basically all we need to check for is, are we processing a hex number? And if we are, we want to set our underscore to OK. And if we get into this else statement, we're going to complain if underscores aren't OK. So basically the reason for that is, let's say we had a hex number 0x32f. Well, if you put a 0x and then an underscore first, we're just basically not allowing the user to do that. We want them to type a number first, and then we can allow underscores in the hex number. And the only way that this else statement is going to be processed is if our hex number is not a number from 0 to 9, and it's not a hex letter from A to F. So it must be an underscore because that's the only thing that we're allowing in our hex number. And if that's the case, then we just advance and continue on. And while we're processing this, we just keep iterating through our number for our current token, and then we just advance. After that, we just get what our actual number is from our string stream, set the type to hex literal, and we set our colon and our line. And in this case, if we complained about this error, we would have already broken out of this while loop and jumped down here. And in this case, if we ever run into an error in our compiler and we're tokenizing some data and we pass in a string of malformed tokenized data, we won't have to worry about running into having to process that later, because we'll stop the compiler because we have compiler errors. All right, so next what we need to do is we're going to start processing a number. Now, the code required for this is kind of a lot of code, so I'm actually going to stop here and we will continue writing our tokenizer on the next episode. But basically, things to note is for this, we're going to be processing numbers of simple integer numbers 1, 2, 3, 4, 5. If we have a decimal number with an integer, a dot, and then a number behind it, so that will qualify as a decimal number. And also considering, since we allow underscores in our numbers, we can have a number with an underscore and also a decimal number. We'll also be allowing for exponent numbers, so it will have an E and then some exponent behind it for positive and negative and so on. So this one's going to be well versed in processing all different types of numbers in our code, so that way as the programmer we can allow them to type whatever type of number format they want. So hopefully you guys enjoyed the video. Definitely like and subscribe if you guys like what you saw and you want to see more. Until next time, see you guys later.